Hello everyone, my name is John Mark Hemphill and I'm the product owner here on VE Studio. Now those of us who are in the business know that creating virtual training solutions and virtual maintenance trainers is a pretty complex task. It can take many people, multiple months to multiple years, it can cost millions of dollars, so just getting started can be pretty intimidating. Well, we use VE Studio here, as well as creating the full virtual training solution, we also use it to prototype early on in the process so that our developer design is aligned with our client vision before we even get started on anything significant. So in previous years, we've shown our MaxLink tool, how we use it through the Fidelity Matrix editor and 3D Studio Max to assign behaviors to geometry. We've shown our requirements analysis tool, how we mark up procedures, how we trace those through the entire process, and how our tool helps us deal with those late game changes by merging. And we've shown our physical constraints system. Now what this does is it allows us to handle those common physical object interactions without requiring the developer to write any code to do so. Now each one of these is a pretty major portion of creating virtual maintenance trainers and virtual training solutions. But in the grand scheme of things, they're all pretty small vignettes. The whole thing to get started can feel pretty daunting, but we think with VE Studio there's a much simpler way to get all this done. So new to us this year is the VE Studio Content Import Wizard. On its face, it's pretty straightforward. We can take models from 3D Studio Max, pull them into the Content Wizard, which will export them from 3D Studio Max using some settings that we need within VE Studio to make things work properly. It'll import them into Unity in an FBX format. All this is pretty standard for an importer so far, but behind the scenes what it's going to do is reach into our Fidelity Matrix, that's a relational database, and add some entries to it that we need in order to process everything. So it's going to add the file object, the component object, all the behaviors that go into describing this, as well as run that initial content processing step within Unity. Now the idea behind this is that when you start a project from scratch, you throw all the max models that you have at this import wizard and come back in a couple minutes and everything is set up and ready for you to start working on your project. Now I'm not going to do that today. For the F16, it does take a couple minutes to perform that import, so we're just going to jump straight ahead to that step. So here we have our F16 within Unity. This is pretty typical of what a customer would send to us for prototyping. Usually they'll send us some CAD that we need to process and just make sure that it's performant, that we can work with it. Or in a case like this, we might just buy a model off of TurboSquid or one of the other model libraries. Tweak it a little bit so that it's ready for us to use. Now before we jump into the scene itself, I want to add some objects so we have some things to interact with. So this is our Fidelity Matrix editor. This is our view of the database. It's one of a couple places where we can add new objects. So I'm going to go into our aircraft here and add a child underneath it. I'm going to add a canopy. Now in real life I know that the canopy requires an electrical system to make it raise and lower, or you need a big hand crank to do so. Today I'm just going to implement it as a door. It's a little bit easier for us to interact with in the scene because of the behaviors that I've applied on it. Now the next one I'm going to add is our power door. That's door 2318, which of course is also going to be a door. Now behind this door we have our power cable. Now this is going to be a piece of support equipment that I'm going to install via the power cart. So the behavior that I'm going to apply is an SE object 3D. That's a support equipment object that the user is going to interact with in the 3D scene as opposed to the 2D scene. And we'll just change some states on it to make it do what we need it to. Now support equipment have a couple different components. Underneath the power cable we have our drop spot. What our drop spot is going to do is tell us where to install that power cable as well as who's going to install it. In this case it's going to be the external power cart. So we'll add a couple more objects in that door. We'll add a switch, which is going to be a switch 3D. As well as a button. And this will be a push button in 3D. Okay, so we have our hierarchy set up. Now we can switch back over to Unity. Now a lot of the tabs that you see here are disti created tabs, so I'm going to open one more of those called the FM tree. Now this is watching our database file, so anything that we do in the database gets updated here as well. So if I expand out the aircraft, you can see all of our objects there ready to work with. So at this stage, all we have to do is take those objects and hook them up to the geometry. So I'm going to select the canopy, select our geometry, and just link to it there. And we'll go closer here. We'll do the same thing for the door. Now, as I mentioned earlier in the presentation, we also have a tool called MaxLink to do this. It just sort of depends on the workflow. Artists tend to prefer to do this through 3D Studio Max. If engineers are working with this, if they're doing the tagging, they tend to prefer to use Unity. Just depends on what the user would like to interact with the system. Now you're going to notice in the bottom right, as I'm marking these up, we have a couple components that are marked as red, needs to process. All this means is that the component itself recognizes that we've made some changes to the geometry that it contains. We're pushing these behaviors over. So we just need to perform a little bit of processing on it to apply those behaviors to the actual Unity objects. Now I have the button selected. When I process this last one, you're going to see on the right side a whole bunch more behaviors get applied to the button. I'll talk about those a little bit more. You see them here. But first, let's go ahead and jump into VR and take a look at the aircraft. All right, let's put on the headset here. Let's grab our controller. So there's our F-16 in the scene. Let's come around to the other side here. Let's open our canopy. That highlights properly. Our power door highlights properly. So there we are. We're able to take a look at a little bit in VR. Now the rest of what I'm going to do here, I'm going to do in desktop mode. It's a little bit easier to interact with the system in desktop mode using mouse and keyboard versus headset and lasers. So let me go ahead and switch my platform here. And while this is switching, these behaviors that were added to the button and all of the objects that I've tagged, they're all disti written behaviors through Unity. So you can write these behaviors, and as long as they're serialized properly, you can push them directly to the database. I use the Fidelity Matrix editor because in the editor we have the concept of these aliases. So a push button 3D knows that it's comprised of a VE push button 3D net behavior, a highlightable object 3D behavior, an inspectable object behavior, as well as a couple of other boilerplate behaviors like the FM object info. It's possible to do this through Unity as well, but through the Fidelity Matrix editor, it's a little bit easier to bulk apply these behaviors. So our normal workflow will be to apply them through the Fidelity Matrix editor, and then if we have changes, go through Unity and push those changes back, change the state, that kind of thing. So I've entered play mode now on the desktop mode, and I'm just going to shrink this down a little bit so we can fit everything on one screen. The final thing that I want to do before writing our lesson is I'm going to tell our message manager that we have an updated version of the database, we have some new objects that were added. So now I'm going to shift over to our training assistant. The training assistant is sort of the brains behind the entire operation. With it, we will assign lessons to students. We can start new lessons for ourselves, resume lessons, manage grades, create after-action reviews, and conduct them. Today, the most important bit, we're going to author a lesson. So we'll create our door 2013 lesson. Now, on the left side of the screen here, you see that exact same database view, hierarchy view. With it, I can expand out. There's my objects. As long as there's a behavior on it that we've defined an action with, we can pull some states out, connect them together, and write a lesson that way. Today, we're going to do something a little bit more interactive. We're going to utilize our live lesson authoring recording function. So all I'm going to do is hit start recording and come over to our virtual environment. We'll come around the side of the aircraft here, and we'll perform some steps to record. Open the door. Let's plug in our power cable. Let's move closer here. We'll flip a switch, press a button, and you're going to see that everything that we do gets added to this left side of the lesson authoring tab. Now it's everything that comes over the network. We don't need quite so much information to describe this lesson. So I'm just going to pull out the important bits. Open the door, plug in the cable, flip the switch, and push the button. And in fact, let's clean those up. Let's make them a bit more human readable. Open the power door, plug in the power cable, flip the switch, press the button. Now I'm just going to connect these. This is a dependency link saying that you have to open the door before you plug in the cable. But for these bottom two, let's say we don't really care what order they get performed in, just as long as they get performed. So I'm going to group them and draw the dependency link just to the group. So this is going to say that just the group needs to be satisfied. However that gets satisfied is fine. So I'm going to stop recording here. And now we need to test out our lesson. So let's shift some stuff over. We'll start our preview mode and reset our state. Now it's in preview mode. All we have to do is go back to our virtual environment, and as we perform the action in the virtual environment, it's going to track what we're doing. So open the power door, take out our cart, plug in that cable, and then we said whatever order we do these in doesn't matter. So I'm going to press the button first and then flip the switch. Now when I redraw the lesson, and you saw while I was going through the lesson, we have a couple added actions that are showing up. These are additional things that came over the network that we just need to decide what we want to do with them. So this first one, the external power unit was set to true. That means our 2D support equipment here, this power cart, was set to visible. That's probably something that we want the student to explicitly know that they need to do. So we're going to take that added action and convert it to a lesson action. We'll just clean this up a bit. Get the power cart. And then these bottom two, we have button set to 0. This is the button coming back up after you've pressed it down. It automatically comes back up because we set it up as a momentary button. But this is redundant information. We already have this press the button step for the student. So in this case, I'm going to mark this as a whitelisted action. What this means is the student can perform it at any time during the lesson and they won't get penalized for it. And the same thing is true of this step here. The aircraft plug is saying which drop spot it got connected to, but we've already told the student up here that they need to plug in the power cable. So this is also redundant information. So I'm going to convert this to a whitelisted action as well. So let's redraw our lesson here. We have our new step, get the power cart, and now we'll go back into our preview mode just to make sure that everything is working as we intended to. So let's come around the aircraft here, open the door. Now we know to explicitly get that power cart out, plug in the cable, then whatever order, flip the switch, press the button, refresh one more time, make sure everything's good, no added actions. So that's it for the basics of our lesson. Usually after this step, we're going to want to record a run-through for our student to watch before they actually execute the lesson in assessment mode. So we're going to switch to our autoplay mode here and just start this up. Now if I go to the environment quickly enough, you're going to see on the left side all of the states got executed with 0 time, and we didn't see anything happen in the virtual environment. However, if we come over to the other side, everything's in the right state. So there are a couple things that we need to resolve here. The first thing is that when I pulled in these actions, all that I'm doing is checking to make sure that it began to move to the state before moving on to the next one. In this case, for autoplay mode, I want to make sure that it's fully gotten to the state that it's trying to move to before moving on to the next one. There's a couple different ways that we can handle this. In this case, I'm going to change the evaluator to an at state evaluator rather than a moving to state evaluator. This will ensure that it makes sure it's at the proper state before moving forward. Now the other thing that we need to do is put the camera in a good position for us to see the action. So I'm going to open my debug menu and take out our iTweaker window. And what our iTweaker window does is allows us to set up the camera and define some transitions, a path for the camera to follow. So we're going to move out a little bit from our aircraft here, just so the student can get some context where that door is. And then we'll zoom in close so that they can see the action here. And then if we play it, that looks pretty decent. So using our same recording function, I'm just going to start recording, emit that event, and now I have my big long camera string. So let's clean this up a little bit. Move the camera. Now this is going to be an autocomplete action. The student doesn't need to do anything to get this to happen, but we only want it to happen during autoplay mode. We don't want the to steal the camera's control from the student while they're actually trying to do the lesson. All right, so we'll go ahead and start autoplay. Let's stop recording here. Move our action bar over. Then we'll reset that guy. Now as we watch in the virtual environment, our camera moves, the door opens, we don't plug in that cable till the door opens, and we don't press the button and switch until the cable plugs in. So that looks pretty good. Let's go ahead and save our lesson here. Now the final stage is let's go from our testing area to our production area. Let's look at it how a student actually would. So I'm running in instructor mode right now. I'm just going to assign the lesson to myself. We'll assume that the student has already gone through autoplay. They've seen the lesson. Now we're going to load it in tutorial mode. I didn't talk too much about tutorial mode in this presentation, but for setting up the lesson the way that we did, you more or less get it for free. In tutorial mode, the environment is going to hold the student's hand through the process. They've already seen the video, so they know what to do, but we want to make sure that the students know the steps well. So every action that the student needs to take is highlighted. So we will open that door. And now if we try to do something out of order, if we try to flip the switch or press the button, it tells us you're not allowed to do that. You have to follow exactly what the lesson says. So we'll grab that power cart. We will plug in our cable here. And now at this stage we said we don't care what order this gets done. Flip the switch, press the button. So it's going to highlight both of those. And as soon as I do one of these, it unhighlights and then the other one unhighlights. Okay, so the student has now done autoplay mode and tutorial mode. We are going to now start this in our practice mode. Practice mode is similar to tutorial mode, except you don't get any highlights and the student is permitted to do everything on the aircraft that they want. But they know this lesson pretty well. They've watched the video, they've gone through the tutorial. So they're going to open that power door, they're going to grab that power card out, and we'll say they forgot, they messed up, they open that canopy, that's not part of this lesson. But they're back on track. Plug in that power cable, we'll flip the switch, press that button. Now this time, when I'm done with the lesson, I'm going to hit grade lesson. And we are presented with a screen with some analytics of how the student did, their raw score, correct answers versus, or correct actions versus incorrect actions, the percentage of what they got right versus wrong, how much time it took them, how many hints they requested, if they got errors, what type of errors they were, and how many they were. Now, if this were in assessment mode, if this were set up in a classroom, this record would be sent to the instructor. The instructor could then compare it against previous runs that the student did. They can compare it against other students in the class. In addition, it stores a video recording of what the student did in their virtual environment. And the instructor can go back in, create an after-action review, insert some comments to the student, and have the student watch their performance with those comments added to make sure that they're always progressing in the right direction. So let's recap what we did here. We imported a new model. We applied behaviors to that geometry. We tested in both VR and desktop in multiple deployments. We recorded a lesson. We tested that lesson in practice mode and tweaked a couple things to make it work. We also modified it for autoplay mode. We added that camera node and we modified some of the states. And we assessed the lesson from the student's eyes in tutorial mode and in practice mode. And we did all of this in about 15-16 minutes. Now, as I've mentioned, this is a prototype that we've developed, but it's not necessarily throwaway work. We can expand this prototype to a full virtual training solution by adding more objects, by adding procedures, by adding models, putting all of that stuff in our database. Now, our database itself, that as well as the lesson engine, as well as all the grades, we have APIs written against them, so you can pull them into a third-party learning management tool or a product lifecycle management tool or anything that you have via the APIs. You can take those autoplay lessons and just do a screen cap recording of them. as instructional videos, upload them to YouTube or whatever your video platform is. Or you can publish to a variety of different delivery platforms. So thanks for watching my presentation. If you have any further questions or you want to get more in depth or a one-on-one demonstration, reach out to us at DISI.com. Thank you.